Good morning. My name is John Jackson, and I'm here to give you the water clarity update for our general membership meeting of the TLPOA of August 26th. What is the Cooperative Lakes Monitoring Program, CLMP? It is responsible for collecting all lake water quality data in Michigan. It includes local volunteers, EGLE, MSU Extension, Huron River Watershed Council, and Michigan Lakes and Streams staff. Myself as the East Twin volunteer and Jerry Beatty as the West Twin are the current TLPOA members. Eric Elgin from MSU is the staff scientist who mentors the statewide volunteers and helps us on our technical questions. TLPOA has participated in the CLMP for 30 years. CLMP has actively monitored lakes in Michigan for 49 years. We currently monitor 3 critical lake parameters: Secchi disk, phosphorus spring and summer, and chlorophyll A. These are the parameters that determine the trophic status. The trophic status is a way to classify each lake on its relative productivity and performance. We also this year in the East Twin Canal had Phoslock applied, like we had the previous year. We also had phosphorus readings taken at a variety of locations. June 12th, we took phosphorus readings before Phoslock was applied. Later that day it was applied, and then on August 2nd, 51 days after the Phoslock was applied, we took another set of measurements. These are the 5 locations that we use for the Phoslock test. And that was location 1 at the end of the East Twin Canal, and then location number 2 was at the knee of the canal, right at the outlet of the 10-acre wetlands, which we have in the past seen very high phosphorus levels from. Then location 3 was at the exit of the canal into the lake. Exit 4 was 100 yards off that exit point, and number 5 was 100 yards off where the retention water dumps into East Twin. The significance here was anticipating highest numbers for phosphorus at location 2 was because like I said earlier, that's what our history has been. However, and that's what we got on the first reading on the 12th of June. And the others were lower. The end of the canal had only 0.15, and then the others were all less than a tenth. However, on the August 2nd, 51 days later, we got I got the reading that I anticipated, showing that the Phoslock, after the first reading was taken, we put the Phoslock down, we got an improvement in phosphorus, about a 30% improvement in phosphorus at this critical point. But what surprised me was we had almost a 500% increase in phosphorus at location number 1 at the end of the East Twin Canal. One of the things that is specific to that location is it happens to be a congregating place for large quantities of geese, and we'll talk some more about that as the presentation goes on. Next, I want to talk quickly about our Secchi disk readings for East Twin. This is the archive. I've shown it. I show it every time, and it goes back to 1939. It's when our first Secchi disk reading, and this year, 2023, these are our numbers. We had one oligotrophic reading. These readings are color coded depending on if they're oligotrophic, mesotrophic, or eutrophic. And you can see we had one oligotrophic reading, and then the rest were mesotrophic. But mesotrophic is where we have been for East Twin, um, uh, basically since we started the CLMP program. And when you look at the total for the year, we've had good success all year. We've been better since the middle of June. We've been better than the previous year, improved over last year. Uh, most of the readings are better than the average has been over all the years, even go back when the numbers were higher. So this 11.4, if we hang in there at a similar kind of level for the last few readings, we will end up with a very good reading for the year, and basically one of the best we've had since year 2000. So good progress there. Now, West Twin has also had SecuDisc readings, and I was asked about that, so I included it on this chart to show what the West Twin performance has been. And you can see that with a 13.3 and a 13.4 in the last 2 years, West Twin is typically 2 to 3 feet better on SecuDisc readings than East Twin. All right, so now let's look at the CLMP results analysis. And what we're going to look at initially here is the trophic status chart. Basically, this is a chart that shows where you are on trophic status. And basically, if you're in a oligotrophic lake, you're down less than 35. If you're a mesotrophic lake, you're between 40 and 45. If you get up to 51, you're in the eutrophic range, 51 to 61. And those are all ranges, classifications for your lake, which is a measure to fundamentally predict the age of the lake. A newer lake, a younger lake, is oligotrophic, and by younger, it's not necessarily a younger in time. It is a younger in the lake productivity scale. The more productive a lake is, which means more fish, more plant growth, more algae, your lake will, as it gets more and more productive, it will slide to the right on this scale. So basically your clearest lakes are out here in the oligotrophic, and that's what our primary concern has been on our lakes, is how is the clarity changing on those lakes. So the West Twin average this past year in 2022 was 39, which is almost to the beginning of the mesotrophic range. That was a great disappointment for us, because West Twin has typically been in this 31 to 35 range, oligotrophic, solidly oligotrophic in the past. And to move up to the mesotrophic was a bit of a surprise. And it was a result of the summer total phosphorus number that was high, and that resulted in this average moving up. The East Twin number, again, the summer total phosphorus was higher than we anticipated, the highest it's ever been in the 30 years we've been in the CLMP, a bit of a surprise, and moved us to the high end of the mesotrophic range, and starting to get into the areas that are considered eutrophic. So the report from CLMP said that West Twin is leaning more mesotrophic than oligotrophic. It's closer to this range than this range. And like I said, that was unusual in the first year that it ever occurred. East Twin has been in these kinds of areas in the past, moving slightly to the right as the years have gone by. It resulted from the slightward upward slopes of all three of the critical parameters. and basically reflectant of a slow movement towards higher nutrient levels of the lake. And it is those higher nutrient levels of the lake which concern us. That is why I put together this next set of slides, which is the East Twin Lake Nutrient Increase and Septic System Survey Update. How do we determine nutrient increases in East Twin Lake? First, you identify and quantify the nutrient increase sources. We're going to use a water flow and phosphorus loading analysis technique that was used in Muskie Lake in Wisconsin. Use the information that we gained from them as it could be applied to our lake, which is a similar lake from the perspective that we're both almost right on the 45th parallel. So from a atmospheric condition, climate, weather condition, we're very similar lakes. So that will have similar, the lakes should perform similarly for atmospheric types of conditions. Also, the thing we really want to do with this nutrient increase is find out what is the relative contribution of each source of phosphorus for our lake, for both lakes. So how do we calculate the annual water flow and phosphorus budgets? Let's first assume East Twin returns to a consistent level each spring. And what I mean by that is when we come back in the spring and the ice is out, the water level of East Twin Canal is, and this would be basically in the end of April, 1st of May, the water level of the East Twin Canal is above a culvert that's directly across the canal from our home, and it's either maybe from 2 to 6 inches above that culvert. So it ends up being a reference point that I can use each year to see how we're doing relative to what we typically do. And it's pretty consistent. The net of that is, that means since we go to the same water level each year, that the water inputs on an annual basis, the water inputs to the lake for the whole season is very close or equal to the water losses we have for that year. That's why the lake returns to the same level. What are the water input sources for the lake? Precipitation, stormwater input from the Lewiston storm sewer system, runoff from the near shore area, and groundwater. What are the water losses? It's quite simple. It's quite simple because, well, even the inlets is simple too, because we have no rivers, we have no creeks or streams running into East Twin. There's no source for it. The water basically is groundwater, ground-fed water and rainfall. The water loss sources are consequently also very limited. The way the water leaves is it evaporates, or it flows through the culvert that flows from East Twin to West Twin. Okay, so the water inputs have to equal the water losses. What is the total phosphorus? It's quite simply the phosphorus concentration in the lake at any one time, times the volume of water. And you can quite simply calculate that if you have a phosphorus concentration, if you know the volume of water in the lake, you can calculate the phosphorus, which is 165. Typically, at this 0.12 level would be equivalent to 165 pounds of phosphorus. How much stormwater enters the East Twin Lake from Lewiston, from the Lewiston storm system? How much water comes in? Well, you look at the area that is covered by the stormwater system where the water flows into, and it's approximately 63 acres in size. You get 37 0.35 inches per year, which is our annual rainfall per the Gaylord NOAA station. You get that, and that falls over this 63 acres. You look at how that would change the water level in East Twin if it was all in East Twin, and it would go up by 2.8 inches of rain a year. Now that assumes that 100% of the water that goes in the storm sewer system goes into East Twin Lake. We know that it's a retention pond. It's supposed to store some water. Unfortunately, it doesn't store that much, but it's going to be some number less than 2.8 would be what goes in, what would be in the retention pond and then leaving the retention pond. And once it leaves the retention pond, it eventually ends up into East Twin Lake. So next, how do we determine what the septic systems around the lake, how much phosphorus do they put in the lake? And so what I used was AI. I used AI, Chat GPT, and it told me, when I asked, it told me to conduct a survey of lake residents using septic fields, estimate the septic usage for each field, the number of people using the field, the number of months each year the field is used, calculate how much phosphorus load comes from each field to the lake, estimating the distance the field is from the lake, and estimating the age of the field. Compare the septic input to the total lake total phosphorus, and consider other factors that may affect other sources of phosphorus. So what are the survey results? We had 245 East Twin Lake properties, of which we had 162 with email addresses. 57 responded. 34% of those that we requested information from, 23% overall. And these were the results of the survey. The survey said those who responded averaged 2.73 people using their septic system for 8.2 months of the year, 249 feet from the lake, with an average age of 30 years. What I had to do then was make some assumptions for those people that didn't respond. So I said for them, we're going to say they have 2 people for 3 months a year, 200 feet from the lake, and 20-year age. That resulted in net values that were used in the equation to actually do the calculation of 2.15 for people, 4.21 for months, 211 for distance from the lake, and 22.5 years for age. You put that information into the formula that we got from the Muskie Lake report. Phosphorus is equal to the export coefficient E sub S times the number of capita years, number of years people are, number of months and years, number of years per person, and then times 1 minus the soil retention coefficient, which is a function of the septic field distance and age. From that equation, you get a sum of phosphorus coming into the lake from the septic systems of a little over 90 pounds. So we got 90 pounds of phosphorus coming from the septic system. So now we have information about all of our contribution sources for East Twin Lake. And those contribution sources are shown on this chart. Now, the way to look at this chart is the items that are in the light green are actual measured data. So we have actual measured data for precipitation, 37.4. The stuff in yellow is stuff we have to assume a value for, but it's not just a wild guess. It is using the Muskie Lake data and adjusting it for those things that are different about East Twin that would be appropriate to use the Muskie Lake data. So for example, since East Twin is much larger than Muskie Lake. We have a larger shoreline. Therefore, with the same amount of water flow coming from the shoreline in Muskie Lake, we would have a 3.1 inch of flow from in East Twin. The storm sewer water, we calculated it at 2.8. I'm saying it, not 100% of it goes in the lake. I said 2.5 inches per year. Groundwater, again, using the ratio difference of the acreage between the two lakes, we would get 20 inches of rain, 20 inches of water into East Twin from the groundwater. Geese, I'm saying that there's 150 geese for the season at East Twin. That doesn't mean there's 150 there every single day, because in the migratory seasons in the spring and fall, the quantities of geese here are much higher than they are on a transient basis. They're coming through, there's maybe stay for a few days, weeks, but then they continue to migrate. This 150 number was what I considered the typical number that we've seen in the lake, and because I'm on the East Twin Canal, I have typically seen up to 60 geese at a time, all at one time, coming up and down the canal outside our place. So that's why I'm saying I know we're not the only place that has a lot of geese, so I guessed at 150. The septic we did the calculation on. Okay, now the amount of evaporation, in Muskie Lake in Wisconsin, again, this lake is at the 45th parallel like we are. So assuming their atmospheric conditions are pretty similar to ours, they had 22 inches of evaporation. Since the amount of evaporation is really not a function of the lake itself, it's a function of the atmospheric conditions, I said if they had 22 inches of evaporation at Muskie Lake, we would also have 22 inches at East Twin. When you take all those water volumes and you know that the increases, those positive ones, have to equal the negative ones, that means that the flow to West Twin must be the equivalent of 41 inches of water in East Twin, which, I'll be perfectly honest, was a really surprising number for me. But that's what the math says, so that's what we have to assume. The other thing that we have measured, and we've done for many years, our CLMP 30-year trend line for spring and summer FOSS. These are the numbers that we've had from a 30-year trend line perspective. 0.01 for spring FOSS, 0.015 for summer FOSS. When you calculate those into pounds of FOSS in the lake, what you find is the summer FOSS, we have a lot more. The summer amount of phosphorus is a lot higher than it is in the spring. And we'll talk a little bit later about why that is. The other thing that was a big surprise for us was, although our spring FOSS in 2022 was a little above normal, not tremendously above normal, like 20%, the summer FOSS number was dramatically higher. The increase we had last year of 10 as compared to typically 5 was a dramatic increase, a 50% increase over what we would have anticipated. And that would mean we had a lot of FOSS in the lake at the end of 2022. So now what we do is we take, because we know the concentrations of each of these types of water going into the lake, we can then calculate how many pounds of phosphorus are from this source. So precipitation supplies us almost 50 pounds of phosphorus. Nearshore water runoff, almost 13 pounds. The storm sewer water, just under 40 pounds. Groundwater, 45 pounds. The geese, 150 geese would put almost 75 pounds of phosphorus in the water. And in fact, there was an article written by RLS in the year 2018 that said that 50 geese will contribute 25 pounds of phosphorus to your lake. And so those numbers certainly jive. We said we got 90.6 from our survey for the septic. Oh, one thing on this storm sewer water, you notice that we have an actual measurement. RLS, the same outfit that we've worked with in the past, came in during a rain event in this and measured the water flow. What are the phosphorus concentration of the water coming out of the retention pond from the storm sewer system? And that's where this number came from. These other numbers we got from Muskie Lake in what they measured. So the net of that is, when you add up all these sources of phosphorus and you take into account that we've got a lot of phosphorus going to West Twin, flowing through to West Twin, the net of that is we would end up with 230 pounds of phosphorus, or we should, this summer when we do the phos readings in September. And I would predict that our number will be 0.017. We'll see how close that is. Now, the interesting thing is that every year the summer phos number is higher than the following spring number. And why is that? Why does that occur? That occurs because of this annual phos, what I'm calling deactivation. And what happens is, if you have a lake that always has oxygenated water, has plenty of oxygen in the water, which we do. We have aeration, we have a shallow lake with a large fetch, wind stirs up the water, boats stir up the water. We get a lot of oxygen in the water. And in fact, even when we've measured dissolved oxygen content, even in the deepest part of the lake, there was always plenty of oxygen there. The significance of that is phosphorus has a characteristic that, particularly when it's iced over and the water is very calm, there's not a bunch of stuff moving around in it, very calm, the phos in the water will combine with iron in the water, and those two will then bond, drop to the bottom, precipitate out, and fall into the sediment, and they will stay locked in that sediment. They can come out of the sediment if you have a lack of oxygen, but that virtually never happens in East Twin Lake. So as a result of that, you have 71 pounds of phos coming out of the water during the winter, during what I'm calling the ice out phase, or we see it when the ice comes out. And that number, that 71, is the difference between this 30-year trend line reading of 213 and the spring trend line of 141. That's where your 71 comes from. So with a 71 pound reduction, I'm predicting that the spring phos next year will be a 0.0116, which seems reasonable. Okay, so from a contribution perspective, the biggest source of phosphorus in the lake is the septic system. Second biggest is geese. Third biggest is precipitation, then groundwater, then the storm sewer water, and the last is the nearshore water. The thing that's important to remember is we can't do anything about the precipitation, the nearshore water, or the groundwater. We have no control over that. We do have the opportunity to control the storm sewer water, the number of geese, and the septic systems. So in terms of ranking our potential corrective actions, if we look at timing, impact, and cost, our most immediate and potential biggest improvement in phosphorus is geese deterrence. Immediate and potentially biggest impact. Don't require permits. We don't have to get approval from anybody. We just need volunteer members to put in some new technology if they're interested in that and see if it helps the geese in their area. And hopefully it does. And if it does and the geese aren't around, then the lake will benefit. The second is the Lewiston storm water control system and improvements for it. The unfortunate part of that is it's got the least potential improvement, meaning it has the smallest contribution. If my model's right, it's got the smallest contribution, but it could be done quicker than we can do the final thing we're going to talk about. But unfortunately, it requires buy-ins from things like the Road Commission, and the Montmorency County Road Commission has been very reticent about doing anything with respect to the retention pond. And Albert Township, now they've been fine if we want to do something, but Road Commission has been an issue. That we're going to need some additional data collection, and I'll talk a little bit more about that later. And that is required for us to get additional outside funding because TLPOA is not in a position to fund the Lewiston stormwater control improvements that we're going to talk about. The last thing we have is the decentralized wastewater system, and this would be the last thing we would consider. And that's potentially the biggest improvement because right now that looks like it's the biggest source of phosphorus, but it requires buy-in from everyone. This is basically a sanitary sewer system for East and West Twin. It requires massive financial support. It's a very long-term project. Similar projects have been presented in the past, and they've always failed. So that would be a real long shot. Okay, what is the board currently doing? We have enlisted Spicer Group Incorporated for our technical help. They're a company that handles retention ponds and sewer systems throughout the state. They manage approximately 300 retention ponds currently in the state today. They toured our situation, East and West Twin, on July 17th in our retention pond. They suggested a three-prong attack. They gave that to us on July 20th. There was some retention pond enhancements, although they weren't that, the retention pond itself isn't that bad, but they could make some relatively easy improvements. The storm sewer system itself needs some enhancements. There's some technology about today that would make that storm sewer collection much better and put less phosphorus in the lake. And also they want to enhance our water quality measurements because our measurements we have today go over a long period of time and they're good measurements, but they're all in one place. And one of the things they've talked about is, and in the analysis I've done thus far, I had to do a bunch of assumptions. And people don't like assumptions. They want measured data. So we need to get some measured data on water quality as well as flow rates. Their suggestion is, and these pressure and flow measurements are needed to improve our analysis accuracy. So instead of having all those yellows that I showed on the chart before, we make those green where we actually take measurements and we put them in those places. That's going to carry more validity than the guesses that I've made. I hope they're educated, but they're still guesses. So the big thing we can do from an input perspective, besides measure phosphorus in some other places around the lake, besides the deep hole where we currently do, is get actual stormwater input from the Lewiston stormwater system. If we're going to propose a change to it, that's probably going to be pretty expensive to the system or the pond, we better make sure we're getting a lot of water out of there, because if we're not, if my 2.5 is inaccurate, then it's going to be less of an improvement than I'm currently predicting. The one thing that it would be very handy to have is more information on the runoff from the nearshore area or groundwater. Now, unfortunately, these are very difficult things to measure. They take a lot of instrumentation. You have to take data for a long time, phosphorus and flow rate data for a long time. A whole year is what they did in Muskie Lake and in a bunch of locations to identify how much water comes into the lake from different places, different groundwater sources. Very difficult to do, very expensive to do, beyond what we are going to try to do, the TLPOA can really handle, because it would be much too long, much more expensive, be much more difficult. The USGS can do that kind of stuff. It was a academic endeavor, so they had a lot more capability to do that stuff than we as an organization can do. The outflows also we want to get some measurements on. Concentration and flow rate. We need to make sure that my assumption about evaporation is legit. In other words, our evaporation rates in East Twin really are similar to what they are in Muskie Lake. The flow rate through the culvert to West Twin is another area very important. That flow rate from East Twin to West Twin is very, very important in making sure our analysis is accurate. And then finally, the flow rate from the West Twin to Cobb Creek is another area that would really benefit us, so we could understand basically the water budget for West Twin as well as the water budget for East Twin. These are where Spicer is planning on making their measurements. 5 in East Twin, 3 in West Twin. One of the things that they're doing is they like to do water quality sampling on the east side of lakes, because in their experience in the past, these are the areas that typically can have some different kinds of not just phos levels, but other concentrations. So they always like to look at the east side. Then they try to get a central point in the lake. We've asked them for some additional algae sampling areas that they thought would be appropriate. Also, we need flow measurements at coming out of the retention pond. We need flow measurements coming into from East Twin to West Twin, and flow measurements going out to Cobb Creek. So those are the things we're looking for. What are our future steps? We have to determine if the summer phos increase we saw in East Twin and West Twin repeat. That's a big concern to both lakes. In the past, we've kind of considered East Twin the area where most of this activity needs to take on to get improvement, but now it looks like West Twin has some issues that we got to get a handle on. And if necessary, we'll have to implement corrective action. Get Montmorency Road Commission and Albert Township to support our storm system improvements. Like I said in the past, the Road Commission has not been, they've been reticent about making changes to that retention pond. And then, assuming we get all this data and it's sufficient, that would give us the opportunity then to write a 319 grant. And what is a 319 grant? I had the opportunity to participate in an EPR webinar this summer, and in it they went in great detail on different ways that the EPA will help fund projects. And one of the areas that they are very interested in is water quality trend and negative water clarity trend. And those are examples of vulnerability factors that they're looking for to give money to. So if we have sufficient data, we will have a good chance of getting some grant money or even a supplement to the state of Michigan budget. Um, uh, why don't we do that now? Because we have a lot of data. Well, when I tried that, they told me my data wasn't good enough. I didn't have too many assumptions. The analysis, although they couldn't find any problem with the analysis, they wanted more data to understand better to make sure we had the real true story of what's going on. So that is one of the reasons why. That's the major reason why we're looking at Spicer to help us with that information. That's it.